Hi all, this is a small video which talk about the descriptive modeling clustering techniques. Okay, the clustering techniques in data mining. So here in this we'll be looking over to what is clustering and what are the various application areas which could be where clustering could be used, and the types of the clustering, and mainly hierarchical clustering and k-means clustering. So this is what our agenda is all about, and also we'll be looking, just touching upon what are the disadvantages of k-means clustering. So what is basically a clustering? Clusters means, as we all say, it's very simple. It's just a grouping of data points in a data set, if you say. So if we have multiple data sets, data points in your data set, you need to group the data sets according to some characteristics, or the similar data has to be categorized into a similar cluster. So here you could see a simple example here. Let me take the pointer. So simple example here, say you have like some triangle data points and some square data points. So they are basically clustered into two different clusters, and you could say that the distance between the data points in a cluster is basically called as an intra-cluster or intra-clustering, and the distance between two different clusters are basically called as the inter-clustering. And always understand, clustering is an unsupervised learning technique. That means clustering is done automatically based on a k which is selected in advanced, and we can select the k based programmatically and as well as manually. So this is what we are going to see, and this is what is clustering. So clustering means that, say we have a data set with a certain set of data points, we need to group them according to certain characteristics, maybe the distance measure, and we will see it how it is done basically on the go. And so here we have this as an input, like we do have the football, and we do have handball, we do have different type of ball here. So when you decode it, so this is your clustering model. So you are basically converting each and everything in onto a or applying these inputs onto a model, and you could see that they are categorized as, okay, these things are categorized as these balls, and footballs are categorized separately, and this is categorized separately. So whenever you see a pattern, you can actually keep them and make them into a different cluster or a group. So basically clustering, with the help of the clustering, we do a grouping. So clustering is basically used in various scenarios, say even in market basket analysis, or to determine the appropriate audience for the product. So you have you have a product company, you have various products in your company, so you want to know, like which product has to be recommended to a particular particular client, or if you are coming out with a particular product, what should be who should be the audience, what should be the price, and where is the location that has to be placed. Everything has to be identified properly. So in such cases, basically you can actually go for clustering. So you can apply the clustering upon the customer base, and you can categorize your customers, and you can decide upon this particular amount which customers will be ready to buy this particular product, and you can target the audience in such a way that that product is sold in a better way at that particular price in wherever location it is. So clustering could be basically used for various scenarios and applications. And another example which I wanted to tell you is about the predictive analytics. So basically there is a book called Predictive Analytics by Siegel. So there is a wonderful example which he has always given. The technique which he basically used for getting more votes, or what is the technique which he basically used in order to make Obama win for the presidential elections for the second time. So this is a great example which he has very widely used for in the case of predictive analytics, and the model which he have basically used is called uplift modeling. Okay, so in that he basically says that the people in US is basically divided into 4 quadrants. Like the sure things are those people who will definitely vote. Okay, so we don't have to even tell them, so they will definitely vote for Obama. So you don't have to disturb such kind of people. and there are certain people called do not disturb. So do not disturb are those people, like, say they are having a double mind, whether they want to vote for Obama or his opponent. So maybe if we ask them, like, please vote for Obama, they might think like, okay, it's a disturbance, so I'll better vote for the opponent. So it is better, like, not to disturb them, because if we don't disturb them, they might vote for, there is a higher chance that we might get the vote for Obama. So they are nothing but the do not disturbs. And there are some lost cases, like, what causes, like, how much ever we try to persuade them, they will not, because they are of the opponent party, so they will definitely not vote for Obama. So we don't have to take care of this cases also. So we don't have to take care of sure things, we don't have to take care of do not disturb, we don't have to take care of the lost cases. Then whom do we need to take care of? Yes, we need to definitely take care of this persuadable. So there will be a set of people who will be like, they are in a double mind, but when you try to persuade, or when you say like, okay, if you vote for him and if he wins and this happens, that happens, they will be ready to vote for Obama. So such people, so in the second time when Obama won, so this is the model which they basically used. So in this predictive modeling, they have actually, reduced the cost to a great extent by only focusing on this persuadables. So that's what the model of predictive analytics. So here, when you will look at this particular 4 quadrants, they are nothing but 4 different clusters. So they have taken the whole set of people of US and they have considered, or they have grouped the people into 4 different categories, where the election, the party, basically spent money only upon the persuadables to get more votes, which made them win the election the second time. And another applications of clustering, so as we have seen, is like the customer segmentation, as we have seen before, then social network analysis and the city planning. So there are multiple applications where we could basically use this clustering for better betterment of the city, maybe to make our city as a smart city, or the city planning, the social network analysis. Okay, we need to identify the people from the Facebook, from the Instagram, from from various other Twitter, so social media, and which all people might be interested in which all things. We need to categorize the people from different social media analysis. So we could use clustering in all the different ways. So there are so many other real-time clustering applications, like identifying the fake news. This is a different area of research as such, which is still going on, where even deep learning and the clustering plus deep learning is basically applied here, and marketing and sales, and then classifying the network traffic, like whether the traffic during a particular time, whether the car traffic is more or the truck traffic is more. So they have in one location they have basically identified that during the night time the truck traffic is more, and during the daytime at a particular situation, like in the morning and in the evening between 4 to 5, and the morning between 6 to 10, the car traffic is more. So you'll be able to categorize and identify the network traffic, and identifying the fraudulent or criminal activity. So this is, this clustering can also be used for outlier detection. So that is one major application of clustering. So it's not only grouping. So sometimes will not be able to group a certain set of data points within any of the groups. So they are basically the outliers. So you have already learnt about the outliers from the 5-point summary and the pre-processing, various pre-processing techniques which you have already learned, right? So there you could understand how you can basically use this for the outlier detection. So any specific major transactions happen which has not happened in that particular account, you could consider that as an outlier and look more detailed onto it to check whether it is a fraudulent activity or a criminal activity. And then document analysis. Okay, you have textbooks, you have novels, you have different genres available. So if you want to categorize the genres into the books into different genres, you could use the clustering technique, and fantasy, football and sports. So in all these different applications, we could basically use this clustering applications. They are all nothing but the various clustering applications. So document clustering, so you are actually clustering the book into technology, the sports and entertainment, so various clusters. So you're putting it into, so it's basically document clustering is an example of example application or real-time application of clustering. So this is what we told. So this is basically the image segmentation. So this is an example which we could see in image processing. So can we use clustering in image processing? Of course, because you could identify the cars and whether the car has been parked properly or not. So you can actually identify it. So you can identify the building, you can identify the people, the post and everything. So this is basically a clustering technique which categorizes the amenities or the items in a particular image. So there are various type of clustering techniques basically. So we have seen about what is clustering, and we have also seen about the different applications of clustering. So now we are moving bit more onto it and seeing about the types of the clustering techniques. So basically the clustering techniques are basically divided into different types, like partitional clustering, hierarchical clustering, density based clustering, grid based clustering, model based clustering. But we will be basically looking more into partitional clustering and hierarchical bit of hierarchical clustering, and the lab we will see about the density based clustering. So this is what we are being basically going to see about it. So types of the clustering which we are basically looking over to is the hierarchical clustering and the partitional clustering. So in the hierarchical clustering, we need to know a little bit more about agglomerative clustering and divisive clustering. And in partitioning clustering, there are so many different clusterings, but we will be mainly seeing in detail about the K-means clustering. So let's move on to the hierarchical clustering. So by the name itself, it's very clear that it is something related to hierarchy, or it is like, either a top down or a bottom up approach which we have to follow, right? So it's very clear about, by the term meaning itself, like hierarchical. So this is an example of the hierarchical clusters. So say you have different clusters, you have different data points like A1, A2, A3, A4. So here in this figure, you could see that you have actually, A1 and A2 is basically grouped into one cluster, then A1, A2 together with A3 is grouped into another cluster, then everything, you could say that it is grouped as one single cluster. And when you see about it, yes, this have, this is basically, this diagram is basically called as a dendrogram, and it's a beautiful diagram which will help you to understand about how the data is connected to or more related to each other. So this is something which you could basically look for. So dendrograms are basically used in representation of the hierarchical cluster. So here it's very clear that A1 and A2 is more close to each other, and this cluster has got a relationship here, and this is more, so altogether, ultimately, the outer layer of your dendrogram, if you take, you could say that it covers whole of the data points in your data set. So this is an example which I wanted to show you. So what I would do is I will just take off this off, so I could play this. I hope this is a So here, this is just an example. So that's why. So this hierarchical, in this, basically you could see that you have different type of cars available here. So there are different type of cars available. So you are basically converting that into, say, blue color cars, and it is sedan and it is hatchback. So there is a sedan car and the hatchback. So the hatchbacks are grouped separately, and the sedan is grouped separately. So this is how it is. Basically the hierarchical clustering is all about. So as I told you earlier, so in hierarchical clustering you have two different types. One is agglomerative and the other one is divisive. And so this is an example which shows you about so this is a video which is taken from Simpli Learn. So I felt like this is a very beautiful video which depicts a lot about how the agglomerative and how the divisive works. So there are certain data points and how it has actually worked. So agglomerative is basically a bottom up format approach. It follows a bottom up format, and divisive is basically a top down approach which is actually followed. So when you look at this thing, you will be able to understand the similar things are ideally clustered together. So this is nothing but agglomerative clustering. And when you look at the divisive clustering, so this is agglomerative. When you look at the divisive clustering, you have to consider from top to bottom. From the top, it actually goes down to the individual points which is available there. So this is how basically the top down and the bottom up clustering approach is basically used in agglomerative and divisive, and this is a concept in hierarchical clustering. So now this is an example of how the agglomerative basically works. So you have various data points in the in a space, okay, in a space. So you have x-axis and y-axis, and all the items are there, and you have to measure the distance, you have to group them, you have to find out a termination condition to stop your operation. So this is what you will basically do here. So when you run this, if you could see that initially you have got so many points, so you're taking the initial points which are closer together, so this one, then you will have to take these two. So you will draw these two as two different data points, p1 and p2, and then you are considering the next points, say p3 and p4. So this is your p3 and p4. Then you have to consider the next points p5 and p6. So you have considered those, and then when you see these two are more related, so you will have a connection here, and then when you made this connection, then these two are now closer, so you can have your whole data here. So this is how the agglomerative works. So this is how you will apply the agglomerative approach and the bottom up approach in the agglomerative clustering. So hope you are able to understand this. So once again, if you see, you have all the points, then you are actually gathering the points, the closest points together. So p1 and p2. So when you see here in the diagram, you have p1 and p2, then the next closest points is p3, p4. So that is actually considered as another cluster. So you could see that as another cluster here. Then you could see that these two clusters are close together, and then when you made this as a single cluster, then these two is close together. So you will get your funnel. So this is a bottom up approach, which is nothing but agglomerative. So you can also come in the opposite way, which will give you an example of divisive clustering. And now in order to have a more idea about how the links between, or how are you basically considering the clusters, or how are you basically identifying in agglomerative and divisive, whether it is top down or bottom up, it is very important for you to identify the inter cluster distances, right? So that is very important. So in the inter cluster distances, you need to mainly identify what are the different type of distances that you can actually consider while calculating the linkages. So this is basically called as a single linkage. In single linkage, say you have two different clusters, you will just identify the minimum distance between the data points between each cluster. And there is an average linkage, because you will find out the average distance of all the data points in this cluster, and you will find the average distance of all the data in this cluster, and then you will find out the average distance. And then there is something called complete linkage. That means that you will take the most distant data points from both the clusters, and you will find out the maximum distance. And there is another type of linkage called centroid. That is, even though you have 10 different points, there is a certain centroid for all those particular points. You will calculate the centroid of this cluster, you will calculate the centroid of this cluster, and the distance between them is basically called as. So these are the different ways in which you could basically calculate the linkages. So these are the different type of linkages. So according to your application, whichever linkage is more suitable for your application, you can actually select that, and you can go with that linkage. So this is again an example which shows you about, say you have initially got 6 data points, and say if you are taking the Euclidean space, so you are finding out the centroid of these 2 points, okay. And then what you are going to do is that, okay, these two are closer, so you will find out the centroid of these 2 points. Then what you would do is that, okay, you understood that this cluster is more closer to this one, then you will find out the centroid between these 2 points, okay. So this is your new centroid point. Then you know that these two are more closer, so what you will do is that you will, okay, this is more closer, fine, so you will consider these two and find out the centroid of new point. So whenever you are adding a new thing, then now these two clusters are basically closer, so you will find out the centroid of the new cluster. So this is how basically you will form the dendrogram, and you will find out how each and every data point is basically closer to each other, and you will find out the Euclidean space, you will find out the Euclidean distance or the centroid between the each and every data points, and each data point will be added to the new cluster, and whichever cluster the data point is added, you will update the centroid value of that particular cluster, and you will keep moving on till you complete all the data points in your data space. So this is what you will do for the agglomerative clustering. So now when it comes in terms of the distance measures, yeah, there are different type of distance measures which you could use. So is it only Euclidean measure? No, it's not only Euclidean measure. You can go for Manhattan, you can go for Jacob, and you could go for the cosine distance, you can go for square distance. So these are different type of the distance measures which are already available. So we'll have a look upon, you know, how this each of the distance measures work, at least a few of them. So the first one is basically the Euclidean distance measure. So Euclidean distance measure basically, you know, just tells you about the distance between two different data points and the length of the path connecting them. So that is what. So that distance is very simple. So you could see the tigress and you could see tie long and the distance between both of them. So if you are calculating it using the Euclidean distance, it is basically sigma of xi minus x1, say tie long is xi and yi is tigress, to xi minus yi the whole square, and you are taking the square root of this. So this is the best proximity measure which is very commonly used. Even though when the data is dense or continuous, we will be using this particular distance measure normally for continuing with the data points, for continuing with for understanding the distance between the two different points. So this is most commonly used one. And then comes the Manhattan distance. So this is basically called the L0 norm or L1 norm, if you say. This is basically the L2 norm and this is basically the L1 norm. So when you say here, it is just the absolute distance between two. So x1 minus x2, you could see the absolute symbol there. You know, you could see an absolute symbol here, okay, and plus y1 minus y2. So this is very simple distance measure which you could use. So you could see the distance between these 2 points like this. And then comes the cosine similarity. So the cosine similarity in k-means, basically we go for Euclidean measure. You could also, so when we go for the document based similarity and all, normally we take this cosine similarity. So cos theta is equal to a dot b by mod a dot mod b. So this is nothing but the formula for the cosine similarity. And then comes the Jacob similarity. In the Jacob similarity, you'll be given with two different set of documents. So these are all the document measures basically. So you'll be given with a certain set of documents and you will find out the union of all the documents and the intersection of all the documents, and you will find out which one is lesser. So this is how you will basically use this Jacob Jacob similarity. So basically see here, intersection divided by union. So 2 by 7 you will get this. So Jacob similarity measures the similarity between the finite simple sets and is defined as a cardinality of the intersection. So cardinality means the number of the points in the intersection and divided by the cardinality of union. So the number of the sets, number of the documents in the union. So this gives you the Jacob similarity measure. And this is all about your various distance measures and everything which we will use in the hierarchical clustering. So we have just seen about hierarchical clustering. So in hierarchical clustering, basically there is agglomerative clustering and divisive clustering. So we have just seen about what is agglomerative and what is divisive, and how what are the various linkages that can happen in agglomerative, and we have also seen about the various distance measures that could be used in finding out the distance measures in this. Now we will see about the partition clustering, so where we will be seeing in detail about the k-means clustering. So now we will be seeing about the partition clustering. So in the partition clustering, we are going to see about k-means clustering. Okay, so let me move a little bit more. So yeah, so we'll see about how k-means clustering works. So this is a flow chart of how k-means clustering work. And this is basically the algorithm for the k-means clustering. So the first thing which we need to know is that we should have a proper data set. So once we have a proper data set which is cleaned and prepared for the processing, we will start with how to determine the k. So k can be identified either by randomly choosing the k as k is equal to 1 or k is equal to 2, or we could also use the technique called elbow method. So that we will see a little bit once we move forward, we will see that technique, but still. And then we have to measure the distance of each of the data point from the k. Okay, say if we have selected two different k's like k1 and k2, then we need to identify the distance of each and every data point from k1 and also each and every data point from k2. So then based on the distance measure, say data point A has got a distance from k1 as 5, and say the same point has a distance measure between, the distance calculated from k2 is say 2, then you have to take the minimum distance. So you have to group that. So you will be putting this data point A in the cluster in the k2. Okay, so in that particular point, so like that only you will be grouping based on the minimum distance, and then you will have to reposition the centroids that we will see. So like that we have to keep doing it. So when you reposition it, if the clusters are unstable, then you have to keep on repeat this process from measure the distance, grouping the minimum distance, and repositioning the centroids. This has to be repeated again and again. So once you feel like the clusters are stable, then it's basically a convergence. So once the convergence has occurred, you could actually, that is nothing but your termination condition for your k-means clustering algorithm. So this is again a simple algorithm for simple algorithm for k-means clustering. So k is the number of the clusters, and d is the set of the left ratios. The initial clusters from the your data set basically. So you will be finally getting a set of k clusters. You will identify the new set of clusters by doing this process. So you will arbitrarily choose a k. So that is basically, initially it is randomly chosen from the data set points. Then you have to assign each object to the cluster, which is based on the distance, and then you have to update the cluster values. Then you have to rearrange them, and you have to repeat this process by reassigning the object to the new cluster. Like that you have to keep moving on until there is no further change. So if you are not able to make any further changes, then which are the clusters which are already there, they are basically called as the final clusters for your data points, which is already there in your data set. So I have already told you about choosing the k. So you can choose the k very randomly. Otherwise, another method is basically like elbow method, silhouette method. There are different type of methods. So elbow method we have already seen in PCA. So we have a set of points, data points in this. So this is your elbow method. So till the elbow you will take, because after the elbow, if you take, it will be exactly like it's kind of an overfitting which is going to happen. So you will not take this. So here when you look at this elbow method, we will take the number of the clusters as 4, because if you take more number of clusters, what happens is that almost all the data points will be in one or the other cluster. So it will be exactly like your original method. So it does not make any sense. So it will be like an overfitting which is happening to the data points which is already there in the data set. So better to take follow this elbow method or silhouette method. So if you are using the silhouette method, this is the formula which you have to follow. You can choose the k based on any of these methods. So so how this works basically, so initialize the k random centroid. So either by the elbow method, or you could just randomly choose it. Initially you could just randomly choose this method, any number of k, then assign the data points to the nearest cluster. So you could use the various distance measures. So Euclidean distance measure or Manhattan distance measures, whichever you want, you can choose it. Then you have to calculate the centroid of those the clusters which are formed, and then you have to repeatedly assign the values, and you have to update the centroids. And finally, if there is no change which is possible, then you can terminate the process. So we will see this. Okay, fine. So we understood that this is the algorithm and this is how it is to be done. How can we basically apply it on a real-time data set? So we would take a small real-time data set and we will try to apply it and see how it works. So let me take the pointer. This is the data set which we have. Say just consider that we have a small data set with A and B points. So this is nothing but your X points and the Y points, and we have got 6 different data in the data set. So now what we have to do is that initially I'm just randomly taking my K as 2, and so the K can be basically taken initially as K1 and K2, but any random points could be taken. But for my easiness, I'm just taking the first 2 points as the random cluster. So this is my K1 and this is my K2. So my K1 is basically 185.72. So this data point, and K2 is this data point. So it's nothing but a point in your space. Okay, so I could take any. So it is not mandatory that I have to take these two. No, I can take this as the K1 and I can take this as the K2. That is also possible. Or no, I want to take something in the middle. That is also possible. So I will take K1 as this one and K2 as this one. No, can I take K is equal to 3? Yes, you can go ahead and take K is equal to 3. But you have to make sure that the number of the K is basically based on either you are going with the sellout method or the elbow method. That would be better. So I'm just taking K1 and K2, K1 and K2. So K is equal to 2 in this particular case, and also I'm taking the random points like K1 as this as the centroid value, the K1 centroid value, and this I'm taking considering as the K2 centroid value. Okay, so now what I need to do, then the next step is basically I need to calculate the distance of each and every point from the K1 centroid value and the K2 centroid value. This is what I want to do. So which distance measure am I using? Is I am going to use the Euclidean distance measure. So square root of x minus a the whole square plus y minus b the whole square, or you could also, because as it is a square function, you could see this formula in these two different ways in the internet. So whichever way, if you see, that they are fine because it's a squared measure. So the sign of the calculation doesn't matter here. So it will just nullify that effect. So here initially I am considering my A as AB points. My AB points is 185. So I am taking the first point in my data set, and these are my clusters. So this is my K1 and K2. And when you understand this, x minus a, so this x is basically the K1 values. So these are the K1 values, and this a and b is nothing but this 185 and 72. Okay. So I am considering, so from the cluster point 1, so my cluster is 185 minus 185 the whole square plus 72 minus 72 the whole square. So this is the distance from the cluster 1, and then I have to take the distance of this point from the cluster 2. So I will get it like 170 minus 185 the whole square plus 56 minus 72 the whole square. So this is where you have to understand that the squaring effect will not cause anything to your sign of the output which you are getting there. So I got it as 21. So the distance of this particular point from the cluster 1 is 0, and the distance of this particular point from the cluster 2 is 21.993. So which one has got a smaller distance? Yes, 0. So this point will be moved on to which cluster? Cluster 1 or cluster 2? Which cluster? So cluster 1, right? So we will be moving this point as in the cluster 1. So this is what you have to understand. Okay. Now we will take the second point. What is the second point? Second point is 170 and 56. So again, you will be finding out the distance of this AB, that is 170, 56 from cluster 1 and from cluster 2. Okay, so from cluster 1, if I say, I would take 185 minus 170 the whole square plus 72 minus 56 the whole square, and the second one 170 minus 170 the whole square plus 56 minus 56 the whole square. So you understood that this point is basically having a 0 distance with the second cluster, and this point is having like 21.93 from the second distance. So which cluster this point will fall to? Cluster 1 or cluster 2, which is having the minimum distance? One is 21.93 and the second one is 0. So of course 0, right? So this point will basically fall onto the cluster 2. So this is how your assignment will happen. So your first point, that is 185, 72 will be falling onto the cluster 1, and this 170, 56 will fall onto the cluster 2. Okay, so this is how the placement happens. So now what you have to do is that you have to take the third point. So the third point, when you take it, you have to consider the third point and the distance between the from the cluster 1 and the distance of this particular point from the cluster 2. So you will be applying 168 minus 185 minus 168 the whole square plus 60 minus 72 the whole square. So you will get this value. This is from the cluster 1, and you have to again find out the same point from the cluster 2. From the cluster 2, you are getting 4.7472. So which cluster? Basically it has to, which cluster? So this point, the distance from the cluster 1 is 20.8 and the distance from the cluster 2 is 4.472. So which one is having the lesser distance? Yes, so this point is basically more closer to 4.472. So it basically falls onto the cluster 2. So now one thing which you have to keep in mind is that in your cluster 1 you have already got this particular point, and in your cluster 2 you already got this point. Now you are adding another point. So you are going to add basically a second point onto the cluster. So what you have to do, you need to update the cluster centroid because there are 2 points now. So what you will do is you will take 170 plus 168 divided by 2. So this is your new cluster centroid. It's centroid, it's just a mean, okay, and it is 56 plus 60 by 2, so you will get 58. So this is your new centroid point. So now you have updated the centroid point of K2 because a new point basically went over to the K2. So there are 2 points. So now you have actually updated the centroid of the K2 to the new centroid value. So now you will take the fourth data point. So fourth data point, if you have taken, you will identify the distance between K1 and the new K2. Okay, so this is your distance from the K1 and this is your distance from the updated K2. This is your new updated centroid. So you will find out the value, and you will get the values as these two. Which one is smaller? Yes, so it is basically more closer to the cluster 1. So now you have already got a value in the cluster 1. Now you are going to add another value onto the cluster 2. So what you have to do, you need to update the cluster. So how will you do that? So you'll be updating 185 plus 179. So 185 and 179. So this point is 179 by 2, and here it is 72 is already there, plus 68 by 2. So you will get the new cluster value which is updated as. So this is your new K1 and this is your new this is your K2. Now again you will be applying the same thing. So you have got the new cluster point. So you will be applying this the distance measure of this particular value from the centroid value. So you will be calculating. This is your so this is how you will be calculating. So here this is 180 70. So this is the new updated cluster centroid. So you will take the values and you will get it as 2, and you will find out the distance of this particular value from 169. Okay, 182 and 72 from 169 and 58. So you will get it as 19.2. So when you consider for this particular value, for this particular data point, the distance from cluster 1 is 2 and distance from cluster 2 is 19.10. So which one you will be assigning this this data point into? You will be putting this into the cluster 1. So now you are going to put the third point onto the cluster 2. So what you have to do, you need to update the cluster centroid. So you will be updating the cluster centroid of which cluster? The K1, right? So you will be updating like 1. So this is the point which is there, and the initial point. So 182 plus 182 by 2 and 70 plus 72 by 2. So you will get this updated cluster point, and the K2 remains the same because no other point has been added to the K2. Now you will again take the last data point. So you will consider the distance from cluster 1 and cluster 2. So you understood that it has to be placed in the cluster 1 again. So you need to update the centroid value. So you will update the centroid value of K1 as this one, and your K2 remains the same. So this is how you have actually got the assignment, so the first point is in the cluster 1, these 2 points are in the cluster 2, and these 3 points are in the cluster 1. So this is how you basically got the data points as how it is basically clustered. So this is this is one which this is the way which you will use the Euclidean distance measure in order to identify each and every data point into which cluster, and you will also update the cluster points to as and when a new data point is added to the cluster, it will automatically update the cluster centroid. So this is another example which I wanted to show you, how the data is basically so you have various delivery points. So these are the various delivery points which you could see. So now what you have to do is that initially you will just randomly select 2 different data points. So when you select this data points, what you have to do is that you have to find out the distance of, say, if you are taking this data point, you will find out the Euclidean distance of this data point between this C1 and this data point and this one also. Like that you have to find out for if you are taking this data point, this one and this one, this one and this one. Like that you have to consider the distance of each and every data point and the different clusters. So once you understood that whichever are the closest clusters, what you will do, you will basically form the initial clusters. So once you form the initial cluster, you have to find out the new centroid value. So you will be finding out the new centroid value, and you will update your centroid value to the new place. So say so you will be updating your centroid value as this one, and here you will be updating the centroid value as this one from this place. So this is your new centroid value. Now you will again calculate the distance between what the data points to the new centroid value, and you will be rearranging the data points to this cluster or that cluster. Like that you will be keep on rearranging the points into the clusters, and finally you will be getting your final cluster as your data points and the cluster. So this is how you will basically do the k-means clustering. So till it is converged, what you have to do, you will be keep on rearranging and updating the centroid values till all the data are there. And this is another example. So almost like but initially all the data points are like this, so you will be coming out with the initial clusters. So when you say that so here they have basically drawn in the case of, so say these are the two different data points which we have taken. So we will fall everything, all these points as all these points into the what is that this one, and these are all the points. Now what you will do is you will update the centroid value. So once you update the centroid values, you will keep on rearranging the data in such a way that okay, these data fall into this one, these data fall into that one, like that you will be arranging, and you will be finally updating your cluster centroid points, and till there is a convergence happening to each and everything, you will be continuing this with the operation. So now what did you understand here? So there is something called curse of dimensionality, which we have already seen in PCA. So when the data has too many features, one major issue is that lot of overfitting. There is a higher risk of overfitting which can happen when you have too many features. Your observations become harder to cluster, so it is very difficult for you to cluster. So if the distance are all approximately equal, then we will not be able to identify meaningful clusters from the data. So what happens is that, so this is a simple example which you could see. So imagine that this is our data set, and so in this data set you have got spicy and all the stuffs, this medium, so different candies. And then when you put them into, so if you are simply putting it as red cluster and blue cluster, it's very simple, okay. But what happens is that when you try to put it like this, so if you see here, these are all red, these are all blue, all zeros. So then these are all blues or all ones, and these are all zeros. So it is very simple, okay. But when you increase the dimension, say if you are like you don't have I want more variance of your red cluster, like I want maroon, I want this the peach color shade and everything. So if you are actually giving more features over to it, then what happens is that the data will become more trouble. It will not have any. So see here, when you see here, these are all the ones, so all of the values are, so that your data will become more sparse. So for you to identify each and every cluster, it will become meaningless. So it is like an overfitting which has happened. So this is actually of no use. So when you are dealing with high dimensional data, then it always causes some trouble for clustering. So that is one thing which you have to keep in your mind. So initially, out of my 8 clusters, 4 are spicy, 4 are sweet. So this is the better way of doing it rather than 8 different clusters. So because then what happens is that then overfitting happens, right? So that's what it is. So this is the major advantages of the k-means clustering is that relatively simple, and you can deal with large data set and guarantees the convergence, and won't start because you start with the position of the centroid, so it works better and easily adapts to new examples. So even if you add new data points to your data set, it is easier for you to follow the same method in order to cluster that particular data point onto the existing data sets. So it is easier. And now the disadvantages is that you can choose the k manually, but when you choose the k manually, then there are so many issues. Otherwise you have to rely upon the programmatical approaches like elbow method or or silhouette method, which is already available then. Then comes the clustering outliers. So if you try to cluster all the outliers, what happens is that overfitting automatically happens, so it will lose the importance of the clustering there. So don't try to include, so just instead what you could do is that you could use this clustering for outlier detection. So clustering could be used for outlier detection rather than not try to include the outlier also into one of the clusters. So if you try to include even the outlier to one of the clusters, then automatically there is an overfitting which is happening, which loses the importance of the clusters, and you will end up with a sparse data. And scaling with the number of the dimensions, it is very difficult, as in the case of your PCA. Here also it is very difficult for you to do it. So you will have to reduce the dimensionality, or you have to use PCA for a dimensionality reduction and then apply clustering. So another thing is curse of dimensionality. As you increase the number of the dimensions, then it loses, or it clustering does have a trouble with properly giving you the results. So this is what it is. So we have seen various things here, like what is clustering, and then what are the types of the clustering, the various applications of clustering, what are the type of the clustering, and then we have also seen about in detail about agglomerative clustering and k-means clustering. And we have also seen a simple problem which we could apply in our real life. So hope you understood this the concept of clustering. So please go through it thoroughly, and if you have any doubts, you can always get back to me. And we will also be seeing about how it could be used in the using the RapidMiner and R tool. Okay, thank you so much. So have a great day. Bye.